12s, well, whenever you're watching this, we're doing our last topic for Unit 3 now. So Chapter 7 is the last in the Unit 3 that will be in the Unit 3 exams, and then we'll start our next set of notes later on for Unit 4. So our last topic is a pretty nice topic, vector calculus. So you've done this heaps in methods, so the concept of calculus using vectors is exactly the same. It's just basically applying what you've learned in methods to this new situation. So when we're finding speed, distance, acceleration, exactly the same rules apply. The thing we just need to know is just remember if we do have a 3D vector, think about what this would look like parametrically. So we know our x components come from I, our y comes from j, and our z comes from k. And so if we were to differentiate each of those, which our normal differentiation rules apply, it would make sense that when we put them back to the equation, that's the differential of the whole vector. So just like you would normally do if you've got 3 separate terms in an equation, you do the same as 3 separate components in a vector. We would just differentiate each part and make sure you agree. So obviously this differentiated is just going to be 6t. This differentiated, the t is going to disappear, so we just end up with 7. And using the chain rule, bring the 3 out, bring the 2 out, and we've got 6 outside of 2t, take 5 all squared. Okay, so no new things, just remembering that vectors can be treated as if they were just a normal equation. So if we've got a particle, we've got a position vector, then we can find obviously the position vector at different values of t, usually time. So we know we can just substitute in when r equals 4. We can find the speed, which we know is just going to be the first derivative to give the velocity vector, and substitute in 4. Okay, and we know because it's speed, not velocity though, we do want the magnitude. Okay, and finally we can find the acceleration, which we know will just be the second derivative, substitute in 4, and obviously always remember to use units. Now we have used meters per second even though it wasn't defined in the question, but obviously a pretty safe one to go with. Okay, so nothing new guys, you're all, I'm sure, very good at differentiation at this point in time. All right, one more quick example. So this time we're given the velocity vector. So we've obviously already got the derivative, and we're told when t equals 5, the position vector is 10i, 104j, 600k. So we can find the speed when t equals 5, so obviously just substituting in 5, and remembering speed is the magnitude. Okay. We want to find when r is 2 now. So again, vectors are exactly the same as normal equations, so now we just want to find the integral, so we can anti-differentiate and find out our position vector function. So anti-differentiate, so remember, make sure that what we've got to be careful with here is that the constant that we add on each time is going to be different. So we need to add a constant for our I components, a constant for our j components, and a constant for our k components. We're told when t equals 5, this is the position vector. Okay, so we can put those in and then work out, all right, so c must be 0 to get us to 10, d must equal 4 to get us to 104, and e must be negative 10. Okay, and then once we've got our position vector, we can substitute in 2 to get 4i plus 20j, take 9.6k. So again, I'm not going to go through anymore because you guys are all really good at this already. If you want some more examples, you can read the beginning to 7a. It does a few more examples with sines and causes and other types of differentiation and integration, but the concept is all the same. So enjoy, and I'll post the last video for Unit 3 later on in the week. Thanks, guys.